Jetzt hoffen wir einfach mal noch, dass es geht. Letzter Versuch jetzt. Aha. No. Now let's see. This is. Is it? Scheint immer noch nicht zu gehen. Ah. Aha, now it seems to work actually. Yes. Hello, Christina, good evening. And now I can see that it seems to work. Okay, all right, sorry for that. I had great technical problems. Now I did everything in the same way as yesterday and the day before. I think so, at least. But now it seems to work that I am live. And I can also see that there are people watching on Facebook. So hello again, and this is the third lecture of the series Geology for the Future of this week. So today's lecture is on energy or energy resources. Yesterday I spoke about other resources. If you would like to invite others, feel free to comment below this video. You may also do this to tell them that it's working now, in case we have lost some of them, the people yet. Today we will not go into a discussion live on Zoom because this took yesterday a little bit long and was slightly out of focus. It was very nice, of course, for myself, but not necessarily for all the others. And Muhammad Kasim and I decided yesterday that we will rather have a kind of live Q&A session sometime next week. And today I will just give this talk and take on your questions that I see in writing. So in case you are watching the replay, feel free to comment as well. I can then also reply to your comments or try to answer your questions afterwards. And well, in case I don't see all the comments during the live, I'm very sorry for that. Also, if I seem to have solved this issue now, it's always the case that Facebook kind of shows some of the comments only much later. So in case I don't answer immediately, please, yes, I'm sorry for that, and we'll reply later, definitely. Yes. I will go through what I have prepared now and will answer the questions in the end of this lecture. Just in case if you don't know me, my name is Sonja Philipp. I'm an adjunct professor at the University of Göttingen in Germany, and I'm also a one-woman company named Geology. Because I don't have a position as a professor, I'm just teaching a course and guide some students in Göttingen. I was an assistant professor earlier in Göttingen, and before that I took my PhD in Bergen in Norway. So my main expertise is in fractures and fracture formation and fluid flow, and my main application is on geothermal energy. And this is one of the topics that we will discuss today. So today's topic is really energy resources. And I take resources as a kind of wide, because geothermal energy is just hot water. So this is also a kind of resource, of course. Just briefly now, yes, sorry. So I will discuss geothermal energy, but also fossil energy, of course, and a little bit also on radioactive waste disposal. I will not talk about the uranium and other rocks that we need for radioactive, so nuclear power, because that was kind of part of the lecture yesterday already. So just to repeat very briefly, most of you know that anyway, is that when we talk about resources, this is really everything of a certain material, be it a rock or a fluid, that exists. And reserves is the part of the resources that we know of already. So we have done enough exploration and estimation of, and know how much of a certain metal, for example, or how much of petroleum is there. But this number can change all the time because of when new technologies become feasible. We can increase the amount of reserves, but the amount of resources we normally don't know of any material. We don't know how much there is, and this is something we will never know. But today I keep this so general, and I will not go into any detailed numbers anyway, because they are always changing. And I'm rather interested in the processes and the problems that are occurring, and would like to add a little bit on what geologists can contribute to these topics. First energy resource is coal. I guess you all know how coal is formed, from deposition from organic material like plants, trees, for example, and then with heat and pressure it's changed into coal. There is various types of coal depending on content of carbon and hydrogen. One very typical rock is brown coal. Here we see a part of Germany's largest brown coal mine. That's the Tagebau Hambach. And this is very well known also in the media. There is a lot on that because they decided last year to remove this little forest there, and it has some species of animals that are only occur in this little wood, and there was a lot of demonstration on that going on. I myself am not convinced that brown coal is any good idea, because it has a very high CO2 production, and there are also other difficulties with chemical processes that are going on during the energy production. And so there are some poisonous material coming out, and this is taken care of course, but it is something that is maybe not necessary to do, and it destroys large parts of the landscape. And in fact, Germany, which is a rather small country in the center of Europe, is the largest producer of brown coal on Earth at the moment. And this is something that I found surprising myself, really, when I read about this, that well, Germans often like to talk about how much they care about the environment and so on, and then we are the largest producer of such bad, really, resource. Here on this slide, you see it's in German, but it's just indicating here that Germany is really, Deutschland is the German word for Germany, and that it is the largest producer at the moment. Well, the numbers are not quite up to date, but it has not changed much since. And you see that there is some amount of brown coal still available in Europe, but the larger resources or reserves, we must say resources really here for the orange parts that are the reserves, and the known resources are the orange part, the darker orange part. So there might be also resources, of course, that we don't know exactly yet. So in Russia and or the former Soviet Union and the Northern America, there are also large amounts of brown coal still in the ground. And well, my personal opinion is that it is not a very good idea to exploit all these. Black coal is a little bit different. That has a higher energy content, and it's also possible to exploit in the subsurface in many places. Here, these are some illustrations from Germany, but it looks similar in other places. So it doesn't destroy that much at the surface, and it is also a little bit more valuable coal, so it's better to produce energy from that. But well, this is definitely not an energy resource for the future, because it is finite, of course. It will end someday. We will have exploited the coal mines, not only in Germany, of course, also in other places. We went into this yesterday during the discussion a little bit, that, well, these resources are, of course, ending sooner or later, depending on, of course, how much we take. Sooner or later, they will end. So black coal or blue coal is not much better than brown coal, but well. So what is very important is the hydrocarbons, like petroleum or natural gas. I guess you know roughly, at least, how petroleum is formed from plankton in the sea, commonly under anaerobic conditions, so with no oxygen. Then it is the source rock can form a so-called black mud, an organic rich dark shale commonly, but this is not petroleum yet. Petroleum forms then when we come at a higher depth. Here this is written in German, but you will recognize the word by Genesis, for example. Well, when we come at greater depth, at the depth of roughly below 2 kilometers, we can form petroleum. But when the temperature is becoming too high in the earth crust, then this petroleum will decay into natural gas that you see here, that below 3 kilometers depth, it's difficult to find still petroleum resources. Or they will not form. They will not form at this depth. Natural gas can also form from decaying coal. But usually we have the hydrocarbon reservoir not in the source rock, but the hydrocarbons are migrating upwards to a reservoir rock, and they are then trapped in structures, maybe a syncline or close to a fault. There are various types of traps. I will not go into details here. But when there is also a seal, that means a rock that is keeping the oil in the reservoir rock, and it cannot migrate further upwards because of buoyancy, we can form a petroleum or a natural gas reservoir. So in order to have a reservoir for petroleum or gas, we need to have a source rock, a reservoir rock, a seal or cap rock, and a trap. And we need to have all these things also at the right time. If the structure that is trapping has formed only after the oil has already moved further upwards, we will not find any oil in a structure. Or yeah, if So a lot of things have to be taken into account here, and this is a quite complex topic that well, there are many geologists working in this field, also together with people from other fields like geophysics and reservoir engineers, of course. In addition to the so-called conventional reservoirs, there are also now non-conventional reservoirs, so-called, that will become more important in the future, like the methane or gas from coal beds, or also, for example, the so-called tight gas. That is a kind of nonsensical term, because it's not the gas that is tight, but the reservoir rock is tight. It has a very low permeability. So but still the common term is tight gas. And there is also the shale gas that is, for example, in the US is very popular now, has started some years ago, and is, well, it's still very much discussed, as you may know, the fracking industry and all the related problems. And well, some people think it is not a good idea, and others say, well, this is such a huge resource for the US, and it makes them independent. Well, these are issues that have to be taken into account, of course. In Germany, we had this discussion as well, because Germany depends very much on natural gas from Russia. And of course, there is some sense in becoming more independent in energy usage. And so there are ideas of developing shale gas reservoirs in northern Germany. There are some rocks that are interesting for that, but at the moment, at least, the political situation is so that it is not allowed. Tight gas reservoirs exist as well in Germany. So I myself worked a little bit during my master thesis, in fact, in old-liegend sandstones, that's lower Permian tight gas sandstone reservoirs. Yeah, so in case there are any questions, please feel free to write them in the comments. I will look at them later. I will not look at that now, because this always takes focus away. As you may know, all the fossil fuels or energy materials are ending sooner or later. And this is an illustration from the Shell study that shows that quite easily, that of course it may be that we have not, these numbers are not exactly correct, but sooner or later oil and gas and also coal will be not available anymore. So there is a need for other energy sources, because the energy demand of mankind is increasing in the future. There are more people and there are more developed countries, fortunately. So there is a higher standard of living, and that also gives a higher demand of energy. So we will be in need of other energy sources. Some of that may, for example, nuclear energy, which I'm not really a fan of, but might be a solution for the time until we have a better production of renewable energies. Renewable energies, of course, also include wind power or solar energy, but I will talk about only the geothermal energy, because this is related, of course, to geology. So geothermal energy has an upward trend in many countries. There are roughly, we distinguish between two types of geothermal energy. The first one is this shallow geothermal energy. Shallow geothermal energy is just in the uppermost few hundred meters. The exact definition is different from country to country, but that is not of the point of discussion here. There we use rather the energy that is stored from the sun inside the uppermost part of the ground. So, for example, through shallow wells, and so it's mainly used for heating houses, but it can also be used for heating larger areas, like whole parts of cities. And it is also possible to store heat in the ground during the summer and take out the heat again in the winter time and heat the houses by that. So the ground is used as a the heat capacity of the ground is used to store the energy. Either it's direct energy from the sun or the energy that we pump down in form of hot water. What is very interesting, I feel, and this is also why I'm working in this field, at least partly, is the deep geothermal energy. There we commonly drill wells of several kilometers depth and pump down cold water and extract hot water. So the water is heated up in the rocks. You see here that in most cases, or in many cases, this has to do with fractures. Either it's natural occurring fractures, or if it's enhanced fractures enhanced by fracking, for example. So we are because fracture permeability is commonly much higher than the matrix permeability, for example, in sedimentary rocks. And many igneous rocks or metamorphic rocks do not really have any matrix porosity and permeability at all. Yeah, well, so we need a rather high temperature, of course, and even more important is a high permeability. And also we need a large volume of rock that we can use, that the heat is not extracted too quickly. What is used really is not the energy that is produced inside the crust. Imagining a rock block that is 1 by 1 kilometers wide and 7 kilometers deep in a kind of average crust. As we have in Germany, for example, we don't have very high geothermal gradient, but that is also similar to many other places in the world. We have a heat production of 4 kilowatt. That is really not very much. A heat flow of 70 kilowatts. That equals to 10 to the power of 12 joules per year. But the heat content is 10 to the power of 18 joule. So the content that can be used is 1 million, would be sufficient for, or is equivalent for 1 million years the heat flow. So we cannot use all the heat that is stored inside the rock, but if we estimate like 20% can be extracted, this equals to an amount of the energy of 400 million tons of crude oil. So there is really a huge reservoir of energy in the crust, and geothermal energy is not possible in every rock, but it is in very many places it's possible. And so it's also compared to other energy sources, it is not very expensive. So, and we also have no problems with CO2 production because we produce only during the drilling, but after that, this is a kind of clean energy that is rather cheap and available in most places. And there is even more energy in other areas that have special geodynamic settings, like also in volcanic areas, like in Iceland or in Indonesia. The geothermal potential is even much, much higher than in this average crust places as we have here. The geosciences that are involved in geothermal energy exploration and exploitation are various. There are geophysicists and rock physicists involved in measuring the subsurface and also material in the lab. Geologists investigate the areas, hydrogeologists are involved and know about pump tests and tracer tests or the hydrochemistry of the fluids that are extracted. Geochemists are involved, and structural geology, or I misspelled that, was still partly the German spelling, sorry, are investigating existing fracture systems and also help in estimating the fracture permeability that is possible to induce in such a reservoir rock. So all these disciplines work together in reservoir characterization and define how to stimulate a reservoir. That means that through fracking or through chemical procedures or other things, we enhance the permeability mainly of a reservoir or increase the volume of a geothermal reservoir. And it's also about estimating the lifetime of a geothermal reservoir, because we of course cool down the rock block somewhat, and it should not take too little time until this rock is cooled down too much, because of course then it's not feasible, it's not economic, and so it should take several decades until the reservoir cannot be used anymore. Then it is possible, of course, to wait for maybe 100 years until the heat flow from lower parts of the crust and mantle has taken, renewed the reservoir. So geothermal energy is not, of course, we extract energy, but it will be renewed with natural processes. So we are not really destroying anything. We are just using the heat flow that comes from below and goes to space anyway, and just reform that so that we can use that. Last little topic is nuclear waste disposal. You probably know that it is very difficult to get rid of the rocks that are used, or the extracted parts of the uranium and other material that is used in the nuclear power production. And so there are various ideas how to get rid of that, because the radioactivity is of course dangerous for us. And well, one idea of course is to send it into space. There are also other ideas like reprocessing the material, so that makes it possible to reuse it, because not all the material has decayed, and so there might be still some use. So the existing deposits are rather close to the surface, and it's possible to place the containers there, but there are some problems with some of them, and at least in many places it has not been possible yet to find really a site where the nuclear waste can be kept for a long enough time. And for long enough, we typically speak about several thousands of years. And it's also one thing, of course, that if we keep it too easily accessible, then it might be dangerous for our following generations that might not necessarily know that these things are there, because there might be other cultures coming in several thousands of years that will not understand what we try to give to them on information. So there are ideas also to make very, very deep wells and bring the stuff very deep down and close it so that it will not be accessible anymore. And well, these are things that are still very much discussed And I'm pretty sure that the generation of geologists that is starting now, working in the professional life, will, some of them at least, will have to do with these processes, these problems. And in fact, I can say that one lady that did her PhD with me, working on a geothermal process or geothermal program and project. So, and she is now working in a nuclear deposit area, and she in fact uses the kind of same methods, at least partly, that she used during her PhD, because in her PhD it was much about understanding fracture systems to obtain find places where we can obtain high permeability, and now she's looking for the opposite. So rocks that have a very low fracture frequency, and so there is low permeability. So there are some processes that are the same, and I personally think it is good for young students or young professionals not to focus only on the problem that they are working on at the moment, but also have in mind that the methods and the things that they are learning can be valuable for other problems that some of them we might not even know yet that will occur in the future. So the contribution of the geologists in energy resources is the same list as I showed yesterday. So we are involved in the exploration of the resources and the exploitation. So it's typical geological work like mapping and interpreting the data from drill cores or from geophysics, making estimates, plan how to exploit or how to bring down, for example, the nuclear waste, and follow the exploitation, what is going on, and take this data into account for replanning the projects. And geologists might also be involved in developing new technologies for exploration and exploitation. So now I try to access the comments and see if I have any questions here. So I stopped that I share the screen, but I should be able to see. So I see that there are people watching here. Okay, I see some comments at least. Susanna said that she is sorry for being late. No problem. Everybody can watch the replay, and you don't have to say sorry. Of course, this is Victor says Guten Tag. Good afternoon from Bolivia. Well, in Bolivia it's in the morning. And he is very happy with this topic. Right, I'm very happy that you like it. Yes, Christina says that there were protests in the Hambach place. There were large protests last year. So there were people living in the forests, and they had to be taken away by the police, or they were taken away from the police in the end. And still, well, the protests have somehow stopped a little, but still there are people complaining about that, and I agree with that. In fact, that I don't think it's a very good idea. Victor says that he would like to know a little bit more about geothermal. Victor, could you please specify a little bit what you would like to know, because this is really a very huge field and it's difficult to answer your question, well, if it's not very specific. So is it shallow geothermal energy or deep geothermal energy that you're interested in? That, for example, would be helpful to answer this a little bit. Where can we learn more about the application of geothermal energy, says Reka? Oh, there are resources from the International Geothermal Association, for example, or from geothermal companies. I could post some links later on that could be interesting. So I see that there must be more comments, but I cannot really see them now. I check once with my mobile if I can see them there. Yesterday I saw different comments on both. So no, I don't see anything else. Oops. Mobile if yes, I have to switch to silent. So there's also always a time lag between so it's always a little bit delayed on Facebook. So it will take some time until I can see what you are commenting. Christina says she has a question about petroleum natural resource. Yeah, well, just write it into the comments and I try to see it. Vayu, or however this is pronounced, sorry, in Ethiopia, East Africa, this time huge geothermal energy is on progress. A company from USA and Iceland to generate 1K by $5 billion. Do you think it's feasible than hydrothermal and wind? Well, the Eastern African Rift is probably one of the best areas to produce geothermal energy from, because you have very high heat, very high geothermal gradient, and you have also a tectonic situation there that is comparable to the mid-ocean ridge in Iceland, for example. So there are a lot of fractures, there is very good permeability, a lot of fault zones that can be accessed, and the geothermal potential of this area is enormous, and definitely this is a very good idea to produce geothermal energy from. Wind energy, well, actually I'm not very much into how much wind there is, and hydrothermal I see as a part of geothermal, so I'm not exactly sure what you mean, sorry. But definitely the deep geothermics or also shallow geothermics is a good idea in Eastern Africa. Sydney says that, are there geologists that work with hot springs to gain access to geothermal energy? Yes, I think so, there are. Yes, so hot springs, of course, are, you don't need to drill anymore, so you can just use the hot water directly. And this is very much used for bathing or also for heating houses. And there are definitely geologists involved to find the best places. So Victor writes now, I'm interested about deep geothermal energy, for example, rock physics and fracture structures for the characterization of rock. As this is what is my field. So, well, but this is really a very huge topic. So I rather talk about this some other time a little bit more detailed. I was planning to do some more lives on fracturing in reservoirs in the following weeks, because this is my field of expertise. And I'm also teaching a course on fractured reservoirs at the University of Göttingen next week. And I will do some more lives on these topics, but this keeps it very much, this will be too much, really, I can talk about this for hours. So just follow, stay tuned, and you will learn more about geothermal energy. If you have specific questions, I can recommend maybe some literature for you. Brandon says, thoughts on direct carbon capture to allow us to continue using hydrocarbons and balance the CO and CO2 levels in the air and oceans. Particularly, do you see us being able to engineer this technology in the near future? Yeah, well, carbon capture is also a very interesting field. In fact, has also similarities with producing oil or geothermal energy, because there we are also interested in having to understand the fracture permeability, also again have a rather low permeability if possible, and yeah, I guess why not? Try to keep this stuff down could be a good idea. It's probably only for until we have better solutions, but for the time being, where we are still using very much fossil energy, this can be part of the solution to keep the CO2 levels in a reasonable amount, or not too high amount. Suranita asks, is the extraction methodology sustainable? Suranita, which extraction do you mean? Do you mean hydrocarbons or extracting hot water for geothermal energy? It's usually more or less pumping up the fluids to extract the energy in both cases. And sorry, I do not exactly understand the question. But if we extract some fluids, in some cases we need to replace the fluids by other fluids, because then we will get different stress fields and problems there. If we kind of empty the subsurface cavities and we alter the stress field, and we can also have some collapse in the ground. So this can be difficult, but in some places the gas or the oil, for example, is replaced with other fluids like water, and then we try to minimize these problems at least. I don't know if this answers your question. If it doesn't, please write another comment or reply to your own comment that I can try to answer this later. Victor, again, do you have the best ideas in a map where geothermal energy can be applied? Yeah, well, you need to have information not only on the rocks at the surface, but on the geological sequence, the strata at deeper depth. And so it's usually not only a map, but also 3D information on the ground. But then you need to know, of course, which rocks are known to have a certain permeability and heat capacity, or so all the rock physical properties. And then with some knowledge about the rock types that are there, you can get at least an educated guess where it is possible to do some geothermal project. In many places, there are databases built up that collect data from very many existing drill holes or other mapping and other projects, and make this available for the geothermal explorationists that to make a first check. But you will always need more detailed investigations afterwards to really find the best place where to drill and so on. Suranita asked for extracting hot water. Yes, this is probably, I answered this. I tried to answer this question already by the fluids, if we extract fluids. If you also mean the extracting the heat, of course, I said earlier that the heat, of course, is extracted during a time of decades usually, but if the reservoir is then not used anymore, for example, they're drilling somewhere close by or deeper at the same place, it takes some time, maybe tens or hundreds of years, and then we have the same temperature as before. So future generations can use the same areas again. And in fact, the potential amount of heat that can be extracted is so high, so large, that it's much, much more than the total energy production or need of energy in the world. So we will not use up all this energy at all, definitely not. The estimates currently are that geothermal energy will take on between 5 and 15% of the total energy production in the future. It will definitely not be for everything, because it's not very easy to produce very quickly. For that, we have rather water power plants, or other power plants. But for the kind of stable base load for power plants, geothermal energy is a very good idea. So I think I answered all the comments that I saw now here. I have checked once more if there are any that I missed. But I see the same on my mobile that I also see on the screen. So I guess I saw most of your comments at least. In case I missed one of your comments, please, I'm sorry for that. Please excuse that. And I will answer to your comments later on. At the lecture tomorrow, I will talk about water. So water is also a kind of resource, but it's also very special. It is about drinking water supply and thermal water, and also has to do, of course, with getting rid of dissolved parts that should not go into the drinking water and into the groundwater. So everything alike, or not everything, but some aspects of what hydrogeologists and other people that are involved in water studies will can add in the future. So there is coming another comment. Shamshad asks how hydrocarbon wells data help for geothermal energy exploration. Yes, they do. For example, from the hydrocarbon industry, we know, of course, well, less at least, what kind of rocks are there, what are the geophysical or rock physical properties of these rocks. Then there is also information, for example, from seismic studies of the subsurface for the hydrocarbon industry that can be interpreted for geothermal industry as well. It is typically, it's not possible really to use the same wells, because the wells for geothermal energy must be much larger. You must take out much more water than petroleum, just volume, because the heat does not give as much energy as if you burn fossil fuels. But you can use all the information, and this gives very valuable information. And it's also that petroleum engineers or geologists in the petroleum industry can be easily trained to use their experience for geothermal exploration in the future. So I don't see any new comments anymore. So in case you're watching this later, you can still leave comments, of course. I will try to answer all your questions and comments later on. And I thank you very much for joining this live, and hope to see you again tomorrow or on Friday, when on Friday I will talk about natural disasters like volcanoes and earthquakes. Take care, bye-bye, stay healthy, and see you again.